Want to get a remote developer job and earning dollars? I'm giving away my full training for free. Check the link and unlock it now. Let's move on to our next lesson about loops. So I'm going to create a new file here called loops.py, and let's start with the definition, okay? So what is a loop? What is a loop? Loop is basically a loops are controlled repetitions. We have some situations in real life where some steps that we take are not multiple steps. They are basically the same step executed repeatedly. Okay? So, for example, imagine a security guard checking a guest list to join a party. For example, to enter a party. What does this security guard do? Basically, step 1, ask the name of the person that is in the queue, the next person. So ask the name of, let's improve this, ask the next person's name. This is the first step. The second step is check if the name is in the list, right? And third step, if the person's name is on the list, allow. Basically, if is not, doesn't allow. All right. So if you see these 3 steps right here, if you pay attention in these 3 steps, basically the security guard is going to repeat these 3 steps for every person in the queue. Okay? So if we have a queue that has 1,000 persons trying to join the party, to enter the party, the security guard is basically repeating the same steps 1,000 times. If the queue has 10 persons, 10 people, anyway, the security guard is going to repeat these 3 steps. And basically, this characterizes a loop. All right? A loop is a controlled repetition where inside of this repetition, some steps are taken repeatedly. All right? And we have some types of loops, some ways of expressing this structure in code that you are going to see in the next topics. Now you know what is a loop, you're ready to implement your first loop. So the first type of loop that I want to show you is the for loop. Okay? Basically, the for loop is a structure where you define the items that you want to iterate through them and what you want to do based on that. In this situation here, we have a security guard in front of a party asking the people that are in the queue their names and checking if this first person that is in the first position of the queue can join the party. If this person's name is in the list, this person can enter the party. So the first thing we need is to represent this data structure, right? So the queue, that is basically the people that are trying to enter the party. So they are John, Mary, Joseph, and Carlos. Okay, and the other data structure that we need is the guest list, right? So guests, who are the people that were invited to this party? John, Mary, and Carlos. We can see that Joseph is not here, right? So probably Joseph is not going to enter the party. Anyway, so we need basically to iterate through this list right here that we are going to call queue, right? And this queue, basically, we are going to check name by name, item by item. And in Python, we have the for loop that helps us to do this in the most simple way that is possible, right? So for queue in queue, do something. This structure, this simple line of code, is going to iterate through the list queue, right? And this position right here, I called queue, but I could call anything, person, name. I could name this underscore because it doesn't matter for me the name of this variable. Okay, this variable right here represents the item of the position that is being iterated. Usually I name it the first letter of the object that I'm iterating over it. So I'm iterating over this queue, through this queue. So the position is going to be Q, all right, the first letter. But I know these are the name of the people that are in the queue, so I could name it name, or I could simply name nothing, okay, just an underscore to represent the position. Okay, in this case I'm going to name it name, and you are going to see that this is going to be iterated through each item. Okay, let's just print name for you to see the loop happening. So when it accesses this position, it's going to print. When it accesses this position, it's going to print. Okay, and let's add a breakpoint and run as debugger for you to visualize the iterations happening. Okay, using the for loop. So let's wait this to start. All right, so now we can see that all of the names were printed. So with this simple line of code, I iterated over every item of this list and printed their names, right? And again, I could name it like Q and print Q. Basically, the value that is in the position that is being accessed is going to be attributed to this variable, and we can manipulate that position individually. Let's clean the console, and now let's run using the breakpoint. Let's debug, because in this case I want you to visualize the iterations happening. Okay, so we are going to see now that in the first execution we just stopped here, and we can see that key in Q is basically John. Can you see here? Q is the list, and Q, the letter Q, is John. If I go to the next step using F10, you can see that it came back for the previous line, because this is a loop. So John was printed, but now we are going to press F10 again, and you're going to see that we are doing the same thing, but now with the next position of the queue, that is Mary, right? And remember, I'm not talking about the data structure queue. I'm talking about the queue itself, the persons, the people that are one after other waiting to enter the party, all right? If we talk about data structure, we're talking about a list, all right? You already know that this is a list, okay? But anyway, if I keep pressing F10, you're going to see that we are going to be getting back to the previous line and the next and the previous and the next, and we can clearly visualize the loop structure going on here, okay? So this is the best way to visualize the loops, in my opinion, using the debug, and you can see what happens inside of the loop. But here we just printed the position. We could do other things with that position. If we access that position, we can check, all right? So if I add here a condition like if queue in guests, I can print can enter, else print cannot enter. Pretty simple. So let's see now who can enter and who cannot enter. We have the loop that iterates through the queue. As we are using the for loop, we are attributing each value to the variable queue. So previously we printed the value, but now we are going to check the value. If the value is in the other list, if it is, can enter. If it's not, cannot enter. We are basically coding the situation where the security guard checks the next person. We just basically coded this, asking the next person's name, checking if the name is in the list, and if the person's name is in the list, we allow this person to enter the party. If it's not, we don't. Okay? We just coded this situation here. All right? Let's run and see. In fact, let's improve this. Let's put the name of the person here. Q can enter. Q cannot enter. Let's change the name to be more readable, but for you to also see that the name that you put here doesn't really matter. Okay, so name cannot enter, name can enter. Let's run this and see what happens. So John can enter. Let's see if it's right. John is in the queue and is in the lists. John is in the queue and is in the guests list. Mary can enter because she's in both. But let's see, Joseph cannot enter. When we checked if the name Joseph is in the guests list, it wasn't. So Joseph cannot enter. So this is how the for loop works. Basically, you can execute the same step as many times as you want. In this case, this queue now have 4 people, but people keep coming to the party. 5 minutes from now, we can have more 10 people and more 1,000 people. Anyway, the amount of items that we have in this list is going to be the amount of times that the loop is going to iterate through the object, through this list in this case that we called queue. In the beginning it's a little bit confusing, but you are going to understand when you practice. But you need to see the power here. If this list had 1,000 people, instead of doing this like if queue 0 in guests 0 in guests print can enter, instead of doing this 1,000 times, we basically did this because it is going to repeat as many times as it's needed and finishes when reach the end of the list, when there's no more items to check. It is going to finish. All right, usually the loops must have a trigger to finish. In this case, the last item of this guests list is the trigger, right? When it reaches the last item, it stops to repeat. But instead of guests, we could have any list here, or any iterable object, an object that allows you to iterate over it. For example, if I want to count from 1 to 10, like I could like write a for loop for underscore in range 0 10. Basically I'm going to reiterate over a list, right? The output of range 0 10 is a list of 10 numbers, and I could print the underscore that represents the position of that list. So let's run this to see what happens. Python loops.py, and we can see that we count from 0 to 9. We have counted from 0 to 9. So if I change 1 to 11, now it's going to count from 1 to 10. Okay, 1 2 3 4 5 and 10. But if I change this to 10, you can see that Python is going to tell me that we have a problem here. Let's try to run this. It is not possible, because for us to be able to iterate over an object, this object must be an iterable object, and 10 is an integer. Iterable objects are basically objects that has many positions. So for example, a list. All right, so this is the for loop, one of the most important repetition structures that we have in Python. But in the next topic, I'm going to show you another type of loop. Stay with me and let's do it. So now you know how to implement a for loop, you know how it works. Let's now move on to the while loop, okay? Because the while loop is pretty important, is often used, and it's also a loop, it's also a repetition structure. But the difference is that the for loop iterates through something. All right, so here we have defined a queue, and we have used the for loop to iterate through this queue. All right, the while loop does not necessarily iterate over something. It just repeats while some condition is true. All right, so for example, instead of defining the queue, let's improve this, because let's pretend that we don't know who are the people that are waiting to join the party. Let's get rid of this queue list. As long as we don't have the queue anymore, it doesn't make any sense to try to iterate through the queue, right? But how can we check the next person now? We can use the loop while. Okay, so while the party is going on, rolling, while the party is party rolling. So while is party rolling, we can get the name of the next person that is trying to enter the party. So next person receives input. What's your name? If next person in guests, we can print next person. In this case, is not the next person. Let's change this just for name. So name can enter. Okay, so while something is true, we can do this. Okay, so we are going to repeat this infinitely, because we are going to repeat while the party is rolling. We are going to ask the name of the person that is trying to enter the party and checking the list to see if this person can enter. Right? Cannot. But we can see here that in this case we need this variable to be true, right? So these are the guests. This is the state of the party, right? Is party rolling? Is the party rolling? True, it is. While the party is rolling, we are going to keep checking the next person's name that is trying to enter the party and allow this person to enter if it is in the list. Okay, let me get rid of all of this, and there you go. If we run this code, we can see that we're going to ask, what's your name? Felipe. Cannot enter. What's your name? Martha. Cannot enter. What's your name? John. Can't enter. You know? So this is a while loop. While something is true, keep doing something, basically. I told you that usually loops must have a trigger, stop repeating, right? Because this is basically an infinite loop. We don't have any trigger that stops asking the next person's name and checking if the person can enter. Because here, while the party is rolling, we are going to keep doing this, right? But we don't have nothing that says that the party is not rolling anymore. You know, we don't have anything that changes the is party rolling variable to false. So if we keep answering the question, what's your name? Our code's going to keep checking and is not going to finish this loop ever. And something important that you need to understand that most of the beginner developers think is that an infinite loop is wrong, but not exactly. All right, there are some situations where you have to use an infinite loop. Just because it's an infinite loop doesn't mean that it's wrong. All right, some situations you can use an infinite loop. All right, but not in this situation. We are going to code now a trigger to stop asking, because we are going to change the state of the variable is party rolling to false when something happens. All right, so let's press Ctrl C here to stop our execution. So in this case, we are going to control the number of songs that have been played in the party. Okay, so number of songs is going to start with 0. All right, and while the party is rolling, we are going to increment every time that we ask someone's name and check if can enter or not, and tell if can enter or not. We are going to increment the amount of songs. All right, the number of songs. This is just an example, all right, for us to have a trigger to say that the party is not rolling anymore. So let's increment this. So number of songs inside of the loop. Okay, number of songs receives number of songs plus 1. Every time we iterate, we are going to add one more song to our number of songs counter. Okay, and this is the basic way to increment, but you can also put like this: number of songs plus equals 1. So this is the same thing of this. Okay, number of songs receives number of songs plus 1, or you can write like this: number of songs plus equals 1. We are incrementing the number of songs. Okay, so we can check if number of songs is equals to 15. We can just set the variable is party rolling to false. All right, so we are basically telling that when the number of songs reaches 15, the party is not rolling anymore. The party is going to end. Okay, and you are going to see that in this case, our while loop is going to finish, is going to stop repeating what's inside of it. Let's print something here to tell that we just stopped. So now the party is over. Okay, now the party is over. So you can see that I'm printing this outside of my while loop. So let's run this loop. What's your name? Felipe. What's your name? Mary. What's your name? Claudia. And our loop keeps asking. So that means that the party is rolling. So let's put data, any data here, and we are going to see that now the party is over. Why? Because this number of songs reached 15, and when it reaches 15, we basically set the is party rolling to false. And in order to our while loop keep executing the steps that are inside of it, this condition must be true. This data must be true. This variable must be true. If we change to false like we did here, it is going to finish the repetition. And the first thing that happens when it goes out of the loop is printing, now the part is over. Okay? So that's how the while loop works. Now you already know how to implement both for loops and while loops. Things are going to start to get funnier. Because now you're going to write nested loops. Basically, one loop inside of the other. When you use some data structures, you need to use nested loops to iterate through them. Because with a list like this, it's pretty simple to iterate with a for loop, right? But how about this structure? This is basically a dictionary, right? This is not a simple list anymore. Let's create a structure to represent a study schedule. So on Monday we study Python, Java, and C#. On Wednesday we study COBOL and Ruby, and on Fridays we study HTML, CSS, and JS. How do you iterate over this structure? Through this structure is a little bit more complex, right? Because if you notice, we have the schedule dictionary, and okay, this is iterable. You can iterate over this item, then this item, and then this item. But inside of each item, we have another iterable structure. That is a list, all right? The value that is attributed to the key Monday is not a unit value, is a list with 3 values in this case, 2 values in this case, and 3 values in this case. So this is one simple example on how to iterate over a little bit more complex structure than a list. And you can use nested loops, one loop inside of the other, all right? So let's create the first loop here to iterate over these items. Okay, so for day comma subject in schedule dot items, open and close parentheses and column. If you notice here, now I am using 2 variables to attribute the values, because in this case my iterable object is not a list, is a dictionary. So when I call schedule dot items, it is going to return basically a list of items of this dictionary. So each line of this dictionary is going to be returned, right? And this line is composed by the day and the subject that we are going to study. So if I run the for loop this way in Python we have this advantage, is a little bit more intelligent than other languages, because it already understands that this variable receives this part of the item and the subject receives these parts of the items, you know. So if I print now day and subjects, you are going to see that I have the values, alright, but I have them as text. I want to print this as a list, like Monday and the items themselves, then Wednesday, the items themselves. So let's run another loop here. Instead of printing, let's run another loop to print the subject aligned in the day of that subject. So instead of printing the items, the raw items, we are going to access each data and print individually, okay? So for example, in this loop, we are accessing this item. So we can print the day, only the day, okay? It is going to run 3 times and print Monday, Wednesday, and Friday. Okay, let's run it again. And we have only the days, all right? And now I'm going to write another for loop, printing the subjects of that specific day. So for subjects, subject in subjects, print subject. I'm going to print like this with a hyphen in front of the subject. And when I finish printing the items of this list, I'm going to print a \n that represents a line breaker to separate the schedule of each day. Let's see what happens, and there you go. We have Monday with Python, Java, and C#. We have the space. We have Wednesday with COBOL, Ruby, and we have Friday with HTML, CSS, and JavaScript. Okay, let's add a breakpoint for you to see the iterations going. So let's run and debug with Ctrl+Shift+D and click run and debug. And this is the easiest way for you to see the iterations going on. All right, let me close this, and now we can see the iterations. So F10 goes to the next step, right? So we just accessed the first iteration. We have the subject. We are going to print the day. We got the first day. F10. We go to the other loop. When it comes to nested loops, we can call this an inner loop and this an outer loop. All right. So we are already inside of the outer loop because we got the schedule items and we split to the day and to the subjects. And now we are going to enter the inner loop. All right, so F10, print the first subject, went back to the top, enter the second subject, went back to the top, entered the third subject, went back to the top, and went out of the inner loop, but still inside of the outer loop. And now if I press F10, it is going back to the outer loop in the second repetition. Okay, F10, print the other day, go to the inner loop again, but now in the second day, not the first day, right? And do the same thing. You can debug and see how the repetitions work. You can add your breakpoint, run in debug mode, and visualize the loop, visualize the repetitions. Okay, and you can even predict with your mind, because this is going to help you to express the nested loop logic when you need. All right, so practice. Like, imagine a situation where you have to run a loop inside of the other, implement, predict the expected outcome, and check if your code matches the predicted outcome with the debug mode. And before we finish, remember, we used the for loop to perform a nested loop, but you can use a while loop inside of another while loop, a for loop inside of a while loop inside of a for loop, and as we did here, we used a for loop inside of a for loop. All right, it doesn't matter the type of loop. If you put one inside another, you are writing a nested loop. Before we finish our lesson about loops, you need to know that we have some keywords that can help you to control the execution flow of a loop. Any loop, while, for, nested loop, combining both, anyway. And not just this type of flow, because these keywords you can use to control the flow of your application itself. All right, in any part of your code you can use these keywords. You are going to understand how they work. I'm going to apply them in the loops. All right, some of them are more often used in loops, but you can also use these keywords in conditions and any type of logic flow that you need to control the execution. You're going to understand when we apply this. So the first keyword that I want to show you is the break keyword, right? The break keyword immediately breaks the flow. All right, for example, let's put a condition here that simulates one topic that is forbidden to study. All right, for example, Ruby. Let's pretend that Ruby is forbidden. Studying Ruby is forbidden. So instead of only printing the subjects, we are going to validate if subject is equals to Ruby, then we are going to break. All right, this is the keyword. What happens here? It is going to immediately break the execution, immediately stop the execution. We are going to see that Ruby is like in the middle of the items that are going to be accessed, right? So it is going to run here, 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 and here normally, but when it finds this position, it is going to stop our loop. So let's run and see what happens. And we can see that we have printed Python, Java, C#, but on Wednesday we only have COBOL. We don't have Ruby. Why do we have the other topics? Because we are using a nested loop, right? So we have this loop right here, and this loop, when it finds Ruby, it breaks. if we had like another languages here, for example, Go, Delphi, you're gonna see that the output is going to be the same, right? We can see here that on Wednesday only prints COBOL. Okay, so that's how the break keyword works. In this case, we could see the other languages because of the nested loop. So this loop was affected by the break keyword, but this outer loop was not. The other situation here is, what if we didn't want to break the loop, but we want to alert that this language is forbidden, for example. We could just print here, remember that Ruby is forbidden. I think that's how you write it. And instead of using the keyword break, I could use the keyword pass. Okay, pass is just a placeholder. Just a placeholder. This keyword itself don't do anything. It's just a placeholder to say that we could control the flow here. This is like a attention point in my flow, and that's why we are printing this log here. Remember that Ruby is forbidden, but we are not going to do anything. We're not going to interfere in the flow itself. Okay, so let's run and see that now it prints the other languages of this session, of this list normally. Ruby, Go, Delphi normally. All right, but we have the alert here in front of Ruby saying that it's forbidden. Okay, or we could do anything we want inside of this part. In this case, we can see that we have printed. Remember that Ruby is forbidden, but we have also printed Ruby. What if I wanted to just to print the alert instead of printing Ruby? I could use the keyword continue, all right? Because when we reach this point, pass is going to do what that part will do and just follow the normal execution flow. But continue is not. Continue is like going to skip what that specific repetition will do, but continue the others, you know? So let's see here what will happen. Python loops, let's see what happens here. We can see COBOL, the alert. Remember that Ruby is forbidden, and instead of printing the Ruby subject, it is going to skip what is inside of this repetition and it's going to the next repetition. Okay, we can debug to see this happening in real time. So let's add a breakpoint here in our inner loop. Let's run with our debugger. I'm gonna click here, run and debug, and let's follow the step-by-step execution to prove the role of each keyword. All right, so with continue, gets the subject, checks if the subject is Ruby. If it's not, just print the subject. In this case, as the subject is Python, this block right here is not going to be executed. Let's keep going. Python, okay. Java, okay. C#, okay. So the first line printed successfully. Let's go to the second line. Now we are not on Monday anymore. Now we are on Wednesday. Let's get the subject. Let's check if it's Ruby. It's not. It's COBOL. So it's going to print. Now let's check if it's Ruby. In this case, it is Ruby. Let's see what's going to happen. We're going to print that Ruby is forbidden. And then we are going to continue, right? Let's see what happens when we execute the continue keyword. It is going to jump immediately to the next execution to get the next subject. That in this case is go. Alright, so this line right here that would print Ruby if we didn't have the continue was skipped. Okay, let's stop our debugging and let's change this continue to pass. We are going to see what happens when we run using the pass keyword. Alright, let's cut the explanation because we already saw what is going to happen in the first line. Let's go to our second line. Alright, we are on Wednesday. First subject is not going to fall in this scenario. It's not going to enter this scenario because it's COBOL. But now we are in this scenario because it's Ruby. Let's see what happens. Print, remember that Ruby is forbidden, and pass. Same thing as not having a keyword. Just went to the next line, okay? And printed Ruby. Alright? And to finish the demonstration, let's break. You're going to see now that break is literally going to interrupt the repetitions. It's going to stop that repetition and is going to finish the execution of that loop. In this case, as we are using nested loops and we are in the inner loop, it is going to finish the execution of the inner loop. But we know that it is going to go back to the outer loop, and this outer loop is going to make the inner loop run again with the next day. All right? So let's demonstrate what happens with break. Now Ruby, not Ruby, now it is going to be Ruby, right? Let's see. Subject's Ruby. Yes, it is. So print, remember that Ruby is forbidden, and break. Let's see what happens. Immediately stops executing this loop, right? We can prove this because Wednesday we have COBOL, Ruby, then we have Go and Delphi. I don't know how to spell it, but anyway. So if we find Ruby, we literally stopped processing the other values. This proves that the break literally breaks the loop. All right. Again, we are only going to get back to that loop because we have a nested loop, one loop inside of the other. And even going back to that loop, we are going to iterate over this day, not this day. So our final result is not going to have every programming language that is on the schedule. All right. We have on Wednesday, we have only COBOL. So these are the keywords that you can use to control the execution of your loops. Most developers have no idea how to get hired remotely. I made a free training showing you the exact steps. Unlock it for free in the description.